takes you 30 minutes after you leave class, but you know, if you don't use your class time, then that kind of adds on to that. So, because you will have class time to work on this. So we want to look at the sum of the angle measures on the inside of a polygon. So I want to add up these angles, and they're not necessarily congruent. Okay? This is the interior. So we're going to find the sum of the interior angles in any polygon. Doesn't have to be regular. If it's regular, then I have some other conditions. So that's what our goal is today. Okay? We're going to look at a problem, and then I'm going to actually go a little bit off the notes and create a chart, which is actually in the homework. Okay, so right there is a polygon. How many sides to that polygon? No, more than 9. Should be 10, right? Now what I have to do, because I get lost in counting my sides, is I have to mark it. Where did I start? Because then I go, oh, did I count that? Because we're going to kind of do some of this chart, so we might as well have it in front of us. Okay, so what I want to do is find, this is one way to do it, and then we're going to do it a different way, which is, I think, a little bit better. Good job. Not necessarily, but. Okay, everybody got the handout. Okay, I'm going to take that polygon and add it in, make up triangles with it. How many triangles are there? Zach, how many triangles are there? 10. There's 10 triangles, and there's 180 degrees in each triangle. But keep in mind, that's adding this angle, and this angle. So if I add up all of them, I'm going to get more than just these angles here on these edges. So it's 10 times 180, and the problem is I don't want these angles in the middle. I don't want those. I just want these base angles. Turns out this is a regular polygon. Doesn't have to be. But if I add up this one, and this one, I'm going to have how much too much? I got a full circle here I don't want. 360. So we'll subtract 360. So 10 is the number of sides, and 180 is the number of degrees in each triangle. So I can come up with maybe a formula that I think will work, that if I take the number of sides times 180 degrees, but I have to subtract off that inner circle, I'll always get that, minus 360. That's the formula we might use. I'm going to show you a different formula, but they are the same. To find the sum of the interior angles in a polygon. Next week, some of you are taking the PSAT, you may run into this. 10th and 11th graders are taking that. So, but you will see it on the ACT and probably the SAT, I'm going to guess. This is the sum of the angles of the interior angles. And yes, we need some 9th and 10th graders for math team, and these are things you need to know for math team. Yes, we do. It's on Mondays. We do little tests, and we have 5 meets, and you compete on these tests. They're not easy.
And with your meet, what do you do? Do you like try to write down quick and fast?
No, you have a 12-minute test, and you have 4 questions. And it's either right or wrong. So those of you who don't like to show work but can figure out answers, that's a good place for you.
Can you use calculators?
Yes, you can use, well, not always, but most of the time you can use a calculator. No, it doesn't quite work that way. Okay, let's try this a different way. I thought this was okay, I'm used to doing it this way. But let's break this up a little bit more. I want to break up my interior into a triangle starting from one vertex. But let's make this a simpler problem. Whoops. Which I'll fill in that chart in a second. First off, if I have 3 sides, I have a triangle, right? How many degrees there? TJ? How many degrees? That's 180. Okay, now if I have a quadrilateral, I am going to break this into triangles. I'm going to start at one vertex, and I have 2 triangles, right? How many degrees in each one of those? 180. Just take a vertex and just draw in the triangles. Okay? N is equal to 5. What do we call that? 5. Pentagon. 2, 3, 4. 1, 2, 3, 4, 5. Okay? Doesn't have to be regular. How many triangles can I get out of this? There's 180. There's another 180, and there's another 180. So it's 3 times 180. Now we'll do the hexagon. I think you start to see the patterns here when I do it this way. So I'm going to start at a vertex. How many triangles can I draw in a hexagon? N equals 6. 1, 2, 3, 4. That's 4 times 180. Are you seeing any patterns here? What if it's, without drawing it, what if n is equal to 7? What's the sum of the interior angles? Not 3, 5 times 180. Well, but what if it's n is equal to 11? Let's try that one. That would be 9 times 180. What's the rule? N minus 2. So that's it. S of I is equal to n minus 2 times 180. So that's one of the first questions on your packet, actually. So if I go to the next slide, I can just fill this in. This is 1 times 180. This was 2 times 180. This is 3 times 180. 4 times 180. 5 times 180. So if it's n, it's n minus 2 times 180. And that's the formula we're going to use today. I don't have one. Right there? That formula was over here. Is it the same? I'm glad you asked that question. Is that the same as n times 180 minus 360? Is that the same as n minus 2 times 180? Yes. You can do it 2 ways. You could distribute. That's 180n minus 2 times 180. Or you could look at this and factor 180 out. So they are the same. And then this is going to be what? N minus 2. I find the second method easier for me. But they're both the same. Okay, TJ? And you know what? We filled this all out, so you have the table. You can just take the numbers right out of that table for your homework. So let's fill in the conjecture right here on this one. It's n minus 2. It's the number of vertices you have, subtract 2 times 180. Because that's how many triangles you can put in there, starting from one vertex. If you think of all the angles adding up, it should make some sense. Well, that's all there is. However, doing the problems, well, initially they're okay, but doing some of the problems are more challenging than that. And that's the problem you're going to have to deal with, is applying these. Okay, we ready to do some examples? Sure. This isn't bad. This is a very straightforward problem. I have a 20 gun, and by the way, it looks almost like a circle, doesn't it? So I recommend you write down the formula. S sub I equals n minus 2 times 180. Now, I can't draw a 20-gon very easily and not make the angles all look congruent. Well, maybe I could. But they look like they're all congruent. But unless you're told it's regular, you cannot make that assumption. So I'm just going to substitute in 20. And so it's 20 minus 2 times 180. I'm not going to worry about the arithmetic today. Yes. Okay. So try the next one. Somebody can tell me what that is. You will want a calculator. I don't have any.
It equals 3,240 for after that one.
What was it? 324?
Not yet.
And some of you say, well, that's awfully big. But yes, it is. It is big. Okay. Now, this is an equiangular polygon. It's a different question. So make sure you read the question. And it says, find the measure of each individual angle in the hexagon. Well, what's true about all those angles if it's equiangular? They're equal. And I want to find out what each one is. So, since these are all congruent, what would you like to call them? A. Well, they're all the same measure. And do I know what they all have to add up to?
Not yet.
Well, they have to, sum of the interior is equal to n minus 2 times 180. Right? You could always draw the hexagon and draw in the triangles, by the way. You don't necessarily have to know this. So it's 6 minus 2 times 180, which is what? 4 times 180 is 720, right? And after you've done enough of these, you kind of memorize the numbers because there are only so many numbers that are going to work. Because what kind of number does n have to be? Can it be a half? Cole, don't do that. No, it can't. Okay, I want to know what each individual one is, but they're all alike. So can I write an equation? How many A's? 6 A's equals 720. That's right, you divide by 6. So A is equal to, 6 into 72 is 12, right? 120 degrees. Does that look reasonable? That picture looks reasonable. Does that measure look reasonable? Yeah. So if you have an equiangular polygon, you're going to take the sum of the interior angles and divide by how many angles you have. So it's S sub I divided by the number of angles. Or S sub I is the sum of the interior angles. Or you could write n minus 2. I don't like formulas, though, over 1 times 180 all over n. I just rather think it through because I can't. There's too many formulas. N is the number of sides. Thank you for asking. Now, this is only true for an equiangular polygon. If it's not equiangular, you can't do that. So like this? Now, we're going to have some that are not equal angled. Yes. That's it right there. It's this formula right here. You take the sum of the interior angles and divide by how many you have. I prefer the green one to the blue because it's less memorizing, it's understanding. Ready? Okay, so here's an example. I couldn't count earlier today, so I'm going to mark a segment right there. 1, 2, 3, 4. I missed that one earlier. 5, 6. So we have a hexagon, right? So n equals 6. That's the first thing you're going to have to do. And I want to find those little red angles. What do you want to call them? I don't know how. B? Okay. Now, these all have to add up to whatever the sum of the interior angles of a hexagon is. I don't care what the shape of the hexagon is. So what is the sum of the interior angles here? It's equal to n minus 2 times 180. When you write that out, you clearly demonstrate to me what you're thinking about. If you just give me numbers, then I have to start there and think, well, what are you doing? So it's 6 minus 2 times 180. We've done this one. What's 4 times 180? It's always 720. How many degrees in a quadrilateral? Four-sided figure. How many degrees in a square? 360. And a rectangle is still 360. Any quadrilateral is 360. So you'll memorize that. That's all of these. 720 is 116 plus 110 plus 2 B's plus that little guy plus that little guy has to equal 720. So you see why you're going to want a calculator. I mean, you can practice with the arithmetic, but it seems kind of silly. So this is 70. So how big is this angle I'm missing right here? It's a straight angle, so it's 110. Excellent. And what about this one? Again, it's another straight angle. 68 plus that has to add up to 180. So what's that going to be? 180 minus 68, 112. So that's what this number is. So if anybody wants to add that up on their calculators, they can, so we get an answer. I have 2 B's. I'm going to solve this equation. So what are these, all the numbers? That's 226 plus 110 plus 112. Who has a calculator and wants to add them up for me? 2B plus, the B's are equal. What's the 116 plus 2 110s and then 112? Oh, you got that answer? 400 and what? 448, okay. And then we solve because we want to find out what B is. Could you have just taken 720 and subtracted all that stuff off? Yes. This is a little nicer. It's a little clearer what I'm doing. This is 136. Oh, I don't know. This is 2, 11, 7, 6, 272. So B is 136. Can our angle measures have decimals in them? Yes. Can the sides have decimals in them? No. If you get one like that, then it's not possible. There's a mistake someplace. Okay, so you see how we're going to apply this? It's just a simple formula, but it wouldn't be any fun if we just gave you quadrilaterals or whatever and said, what's the sum of the interior angles? We're going to make it a puzzle. Okay, that one looks harder. It's really not that bad. So let's take this rectangle. Well, it's not a rectangle. It's a quadrilateral. So what's true about H plus 66 plus that one? We'll have to figure out what that one is. Plus, what's that other angle over there? 90. And all quadrilaterals add up to 360. This one here is 130? How'd you get that? Not necessarily is it congruent. Nope. Nope, that's not going to work. Let's call that X. I just put an extra one, 130. What's true about X plus, this is X, 130 plus 108? That has to add up to how many degrees? I'm going to go all the way around that circle there. Oh, 360 in the circle. So X plus 238, right? So if I subtract that, $122. Now, can you find H? Harrison, can you find H? You have a calculator? Who's got a calculator? I want 66 plus 122 plus 90. 278? Okay. Then what, when you subtract 278 from 360, you get? 82. Is that right? Looks right. Okay. There's 2 problems in this problem, though. Okay? What about this one? Hey guys, Colin, what about this one? This is a what figure? Let's see. 1, 2, 3, 4, 5. It's a pentagon. So what do you want to call these angles? We already have B's. Oh, no, not in this problem. We don't. Okay, so you have 2B plus 117 plus 108, TJ. Oh, how many B's do I have? Not 2. I have 3 B's. I missed that. Has to equal, well, I don't know how many degrees in a pentagon. Well, so we have to figure it out. It's 5 minus 2 times 180. So I have 3B plus 117 plus 108, because it's sloppy. What's 3 times 180? TJ? What's 3 times 180?
3 times 180 would be 5.
3 times 20, it's about 20, it would be 60. It's going to be smaller than that.
5. Oh, it would.
Yep, just using some little common sense there. Okay, this is all arithmetic, which I find annoying. Isn't it annoying?
Yeah, so annoying.
2, 1, uh-oh. 225, isn't it? 15 equals 540. Yes, you're going to use a calculator. That's what I said. You will want a calculator here, won't you? Oh, I don't need to borrow. Whoops. So that's going to be 3. That's 5, 1, and 5 and 2. Yep, that's right. So 3B equals 315. And so B is equal to 315 over 3. I think I did it wrong in another class, but I think I missed a B. Okay, so 1, 0, yep, 5. Okay? Okay. Any problems with that?
None at all. That's a lot of work.
It is a lot of work. Wait till you see this one. Now, this is just scary looking. There's a homework problem like that on the back page. And, oh, it's not that bad. We'll look at it. And then we'll do those. We got a lot. And that's last picture. There's on that problem number 12, you're missing that angle. For being correct?
I don't know.
Maybe, maybe not. Okay. No, you didn't, because now you'll do well on your quiz today. Okay. I want to find the measure of each angle in the trapezoid. If you're trying to put this window, this actually comes from Mrs. Spears, one of her projects. She put this window into her house. You have to know that angle. So here's the trapezoid. They're all the same. It's a regular octagon. Okay. So I need to find these angles. Yes, it looks more complicated than it is. It says find the angles in the trapezoids. Okay? So, you guys, I want to find this angle. What's true about all these angles right here? They're all congruent. So you have 8 of those. Call it x. So 8x equals, I don't know how many degrees in an octagon, so I'm going to have to use the formula. So it's n minus 2 times 180. So it's 8 minus 2 times 180. 8x equals 6 times 180. What is that? 1080? So x equals 8 into 1080. Goes once, 8, 28. That's 3, 24, 40. That's 5, 135. Okay, that's each big angle. Okay, TJ? That's this one. What do you think is true? We don't really have a theorem about this, but what do you think is true? What is that ray doing to this big angle? It's bisecting it. So this is half of 135. Now, so how much is that? 67.5. And there's a lot of ways to get these other angles. But the easiest way, I think, is to know that that's a quadrilateral. So I've got 2 times 67.5 plus, let's call that y. I have 2 y's, and that has to equal how many degrees in a trapezoid? It's a quadrilateral. 360. 360. That's what I want to find out is what's y. So you get 135, it's going to be a decimal, plus 2y equals 360. You're going to subtract 135 and get 225. Is that right? How did I get what? There's 2 of these guys, and then you have 2 of these, and they're all, these other ones are equal. I also know something you don't know, that this angle here in my trapezoid and this one here, because these are parallel, those are supplementary. So I could have just subtracted from 180. Yes, y is 112.5. If you're going to install this, you need to know those angles, and you need to put this window together correctly, and you need to measure it correctly on your wall. 67.5, yeah. There's just the 2. It says find the measure of each angle in the trapezoid, just the trapezoids. We could find this if we want, but we don't care. Yeah, 67.5 and 112. So I should circle my answers. Okay? Now, just a little different way of looking at this. I give you now that the sum of the interior angles is 1080. How many sides do you have? So the formula is this. Now, where am I going to put the 1080? Whoops. Where am I going to put the 1080? I'm going to put it right here. Somebody quickly divide that out for me. I think it's 6, isn't it? 180 divided, 1080 divided by 180 should be 6, I think. It's 6. Yep, we just did it on the last problem. Now, where do the mistakes happen on this problem? You look at this equation and you tend to subtract 2. I don't want to subtract 2. I want to add 2. Yes, so n equals 8. Okay? This is the last one. If each angle in a regular polygon equals 120, how many sides does it have? Okay, so I'm just going to draw a regular polygon. I don't know what it is. And this is 120. And the question is, how many do I have? I don't know. So each angle equals 120. What's the sum of the interior angles? Well, you have 120 times how many sides there are, right? But there's another formula for the sum of the interior angles. It's that n minus 2 times 180. What has to be true about, if these two are the same, what has to be true about the right sides? They have to be the same. So 120n equals 180 times n minus 2, and we just solve. Because it's equiangular, it's regular. If it wasn't regular, I couldn't do this. The sum of the interior angles, I got 120 for each one of those vertices. There's n of them. I don't know how many. Could do guess and check. And then it's, so I know that, and I also know that if I can find the sum of the interior angles by subtracting 2 from n and multiplying by 180, no matter how I do the problem, it's got to be the same. So I just set them equal. So 120n equals 180n, whoops, minus 360, which is our very first formula. Subtract 180n, TJ, and what do I get? Call. Because you might have to do something like this. Negative 60n equals negative 360. So what's n equal to? Divide by negative 60. That's not adding. Divide. So it's 6. Two negatives make a positive. Got to have a positive number, right? So it's a hexagon. Now, after you've done a number of these, you just kind of know. I know that the hexagon's 120 degrees. And I use that quite often later on. Yes. What did I what? Because the sum of the interior angles is this, 180, n minus 2. But another way to find the sum of them is to add up the 120. But I don't know how many vertices there are. So I call that n also. It's the same number. And that's it. Now I'm going to collect your homework. Are there questions on homework? Because I want to give you a quiz. The quiz is front and back, by the way.
Give us back the quiz.
No, I have to give you the quiz. That one? Okay, so you should have checked your answers, and in the interest of time,